So hello everyone, I'm Hugo Bruhier, I'm a postdoc on the SAFE project funded by Manutech-SLEIGHT, and I will talk to you about ultrashort laser-treated PVD zirconium copper-based thin film metallic glasses for biological applications. So first of all, what are metallic glasses? They have some particular interesting mechanical properties, and they are amorphous at the atomic scale. The thing that amorphous induce that we do not have any metallic grain defects, which induce that we have a very good response rate here with here with yes. Here we can see that we have a lot of more bounds here than on regular metallic materials without metallic glasses. They're kind of unusual material because with two metallic atoms, we have the alloys, which are well-known materials, but we do not want to have alloys, we want amorphous phase. So we have to use some non-aquarium process, magnetosputtering, to create these metallic glasses with high cooling rate. And we have a lot of parameters, important parameters that are the composition of the thin film, the two atomic composition here for zirconium and copper must have different sizes, the atoms, and also different crystalline structures. And also we have all the deposition parameters as a choice to control the properties of the thin films. And we are work here on the zirconium copper metallic glasses. Direct measurements on metallic glasses with composition of copper from 25 to near 100% of copper shows that from 30 to 90% of copper we have amorphous thin layers, but with matte images we see here little crystallites, and the absence of crystallites, the perfect amorphous phases, are only for near 50-50 composition. Here's the matte image and the diffraction pattern of the image. Also, another way to check the metallic glass properties is to check the metallic glass transition here near 300 degrees. Also, when we cut the metallic glasses, the thin layers, we see this vein-like pattern, which is very important, very particular to metallic glasses. And an interesting property of these metallic glasses are their very low surface roughness at about 2.5 nanometer just after the deposition process. It is well known that metallic glasses can have some bacteriological properties linked to the wettability of the surface and the surface structuring. We have a lot of possibilities to make structures of the surface, like chemical attacks, thermoforming, or lithography. But in this project, we want to use some laser irradiation process, which permits to have structures from the micrometer to the nanometer at large scale. And the advantage is it's a very flexible method, and we can have a lot of structures just by changing just some parameters, structures like lips, LSFL, HSFL, holes, bumps, spikes, etc. And also it's a one-step method. Just the irradiation process, and we have a texturation of the surface. We have all the possibilities, the physical interaction between an ultrashort laser pulse and the surface with some cavitation, spallation, ablation, etc. And which is important here is that we have a texturation with topographic and chemical changing are the surfaces. So to increase the possibilities of make some textures, surface texturings, we worked also on pulse shaping, temporal pulse shaping with double pulses, which permits to have a lot more complex geometries. The setup is shown here with Mach-Zehnder interferometer with a delay line. And by moving this delay line, we can choose the delay between the pulse to 0 to here 70 picoseconds. We have a lot of parameters. The delay, also we have some half-wave plate and polarizer to control the direction of polarization of each pulse, the recurring of the pulses, the repetitions rate, laser fluence, etc., etc. All these parameters permit to have a lot of reachable topographies, and when we want to have large surfaces, we can also use a scanner with moving mirrors, and it's a very fast method because we can have a speed of the beam at the surface to the meter per second, which permits to make very large surfaces in a very low amount of time. The first results are shown here with an hydrophobic behavior. At the environmental SEM in humidity mode, we are surface with LSFL. We see that we have a droplet orientation, a modification of the droplet. We are not circular droplet, but oriented water droplet. And by increasing the humidity at low temperature, we can see that the droplets forms only outside the textured surface, and inside the textured surface at the very vicinity of the texturation, we do not have any droplets. So we saw at the microscopic scale that we have a very hydrophobic behavior of the surface. To also check the chemical properties on the bacteriological behavior, we have ternary thin film metallic glasses with adding silver to our zirconium copper thin films, made with arrays with a lot of composition of the thin films. We saw that for each composition, the DRX measurement show that the oxide measurement show an amorphous characteristics, and also when cutting the thin film, we saw the vein-like, so we are amorphous and we are metallic glasses. By checking the biological properties, we saw that the antibacterial activity for H. coli and Staphylococcus aureus shows that at 11% and 25% of silver, we kill all the bacteria. And we can also make a scan of the silver concentration, and here we have the live bacteria in percentage, and we see a rather linear shape here. So by increasing the percentage of silver, we can change the bacteriological property of the thin film. We checked also that the wettability is not changed by changing the percentage of silver, so these bacterial properties are only linked to the chemistry of the surface and not the wettability properties of the surface, just by adding more silver into the metallic glasses. So as a conclusion, we made some PVD fabrication of zirconium copper and zirconium copper silver thin film metallic glasses, and their stability up to 350 degrees. We have smooth amorphous surfaces, and they are chemically homogeneous. We made some femtosecond laser radiation and texturation with a change of wettability checked at the microscale in environmental SEM, and a biocide effect just due to the chemical effect of the silver metallic glasses. The perspective is to make new iteration on this ternary thin film and understand the link and the correlation between topographic and chemistry at the surface on the bactericide effects to have new type of structures, some multiple structuration, and also complexify the radiation process with some pulse shaping, complex polarization in order to obtain new types of structure into metallic glasses. Thank you for your attention.